This presentation is somewhat technical, so we'll start it off easy, and happy to take more technical questions as we go along. All right, so a bit about me. I finished my PhD at MIT in CS, so when I'm not giving talks, I'm writing Kubernetes code or training BERT models, and love doing that. Part of my thesis work was a system called ModelDB. It is a database for models, so keeping track of all the models that are being built and then also tracking them as you go through to production and monitoring. So it's open source and remains so. And Verda is an evolution of ModelDB, where we are building a platform for model lifecycle management. And I'm not going to be talking a whole lot about Verda here. We have a booth outside that please feel free to check it out, and happy to give you a demo then. Today what I'm going to be doing is threefold. First, I would like to convince you that to make AI projects successful, teams need to think about how to practice Agile in the context of AI and ML. I'll talk about what it means to be Agile in this context, and then I'll go over a case study offering some proof that this actually works if you set up your teams and tools right. All right, let's dive in. So based on all the talks so far, I think all of us can agree that there is a shift in AI and ML, data science, if you, whatever vocabulary word you like to call it. We're going from a insight generating data science activity to what I think is production machine learning. So the outcomes are no longer, here's a slide deck and we should put this store in this particular area. It's more along the lines of, today our customers are doing X and therefore we should give them these recommendations. It's much more dynamic, it's much more interactive. And as a result, what's happening is the old model lifecycle, which used to be procure some data, analyze it, visualize it, build a model, and then make a PowerPoint, or if lucky, put the model behind an API. That's changing to more of a software lifecycle for those who are more familiar with SDLC. You got the data, you built the model, you ran experiments at scale, because hey, we all work with millions of rows of data. You roll out the model, you see how it's doing, and then you find new ways to improve it, and then you keep going. So a few talks talked about their version 1s of the model, version 2s of the model. That's what we're talking about here. And as we transition from the old model lifecycle to the new one, we find that data science is getting closer to software engineering than it was to research. So we care much less about the best model. We care about a model that works and then iterating on it once it's deployed. And I would argue in particular that we're getting closer to agile software engineering. So it's not about perfection, it's about how many repetitions you get in. And this has worked super well for software, and we think it works well for AI and ML as well. So what's agile? People familiar with agile in general? Okay, perfect. Agile is awesome. Sprints, Jira can have mixed feedback, but the general idea. The goal is to improve the efficient delivery of initiatives and to improve delivery times and reduce risk. And we've built Facebook, Google, all based on kind of those principles. So why AI? Why do AI and ML also need Agile? The first one is that there's a lot of research that's going into NLP models, BERT models, XLNet, that's great. But the only way you figure out if a model is working is when it goes into production. The iteration cycle that I mentioned is the only way you find out if your model's working. You find out funny things when something goes into production, like, hey, my data is missing values and I don't have good checks and balances to figure out what's going on. Also, the fact that you need to do A/B testing with respect to a simple model that just maybe predicts the most frequent answer. Totally valid model. And then one that we care a lot about is model monitoring. Just like code has monitoring built in, PagerDuty, New Relic, those tools help us make sure that our web servers and our applications are working as expected. Similarly, models also need monitoring. Finally, we're not going to just build one model, right? We're going to build tons of these, whether it's for tagging, it's for taxonomies, classification, pricing, and so on. And at some point, we're going to be able to reuse these models across the organization. So being able to share models turns out to be key for enabling your teams to move as fast as they should. So this is not just us. This is a broader trend. I run the SF Bay Area Agile AI and ML meetup. Salesforce actually has a wonderful talk series on Agile data science that I encourage you to check out. They talk about how they implemented Agile practices in their practice. And of course, Google has been at the forefront. This is a very highly cited paper. I encourage you to check it out as well. So how can you do this, right? You want to be Agile. What's involved in it? So there's usually two things with implementing Agile. There's the tools that help you go fast, and then there are the teams. I'm not going to be talking about teams in these 20 minutes, but happy to chat offline. I'm going to focus on tools because that's what I built for a living. So if we take a step back and think about the current challenges for enterprise AI, we think they're fourfold. The first one is ad hoc model development. So everyone does their own thing. We ship our notebooks around on Slack, and then we think we're going to deploy a model that was built in these notebooks. Really doesn't work that way, or shouldn't work that way. It's hard to pick up a new project when someone either switches to a different project or leaves the team. We've been in different cases where we spend months regenerating a model just because someone hadn't kept track of their experimentation history. The third one, I think I've heard it a lot today, is how do you take models from development through to deployment? And Dockerization, Kubernetes helps a lot with that. And finally, performance decays. So this is a large company based in Seattle. They built a chatbot called Tay. Started off super nice and polite. A few days on the internet, and it's abusive and racist. Clearly, we can't have that. We gotta do better. So if we draw a parallel to software engineering, we find that we have tools across the board. We have Git. People know Git, right? Code versioning. We have GitHub, where we collaborate and share our stuff. We have things like Jenkins, CircleCI, that does deployment. And then we have monitoring. So the point is, code can move a lot faster than models because we have this infrastructure. And the moment that we can enable this for ML, we're going to be able to be Agile with ML as well. So at MIT, we got a head start on this problem. My PhD thesis was building the system called ModelDB. It's open source, check it out. And at Verda, we're doing the whole thing. So what we've seen over and over again is better infrastructure can enable teams to be more agile. And so whether you're building these systems in-house or you're piecing them together, these are the 4 challenges that we found as being key to solve in this transition. All right, so for the remainder of my time, I'm going to be going over a case study where we helped a mid-sized company implement Agile ML and how we went about doing that and some lessons. The hope is everyone here can derive some ideas for how this can be implemented in their teams as well. Bit about this company. It's a B2B sales automation company. So they find you B2B leads that look like your current leads, and they do a fantastic job of that. It's 100 plus employees. It's a 5-person data science team, so reasonable size. And their charter is to build advanced AI models to identify better leads for their customers. And these folks were already using the agile processes, sprints, Jira, super resourceful and driven data scientists. The team structure is interesting, and I think it also mirrors things that I've heard today, where the data science team is kind of small. They have 1 or 2 folks from engineering supporting them, but there isn't like a full-fledged 100-person org that's going to support the data science efforts. So as a result, the key challenges for this team were as follows. Slow model development and deployment time. This should look familiar. There's a large overhead in just validating models at scale. You might build your model with just say 10,000 records, but then you want to test it on millions. How do I do that without fidgeting with Celery workers or other AWS constructs? There's usually also a hard dependency on the engineering team because they need to allocate resources where they can deploy your new amazing model. And as a result, we found that there was a gap of multiple months before teams were able to deploy models. The second one was the lack of ability to innovate in models. So do folks work in Python here mainly? Okay, so Python 2 and Python 3 is a bane of many people's existence. Your production systems will be in Python 2. If you're lucky, they'll be in Python 3. But a lot of the ML models work with only certain versions of Python, of scikit-learn, of PyTorch for TensorFlow. And as a result, unless you have the ability to define your own custom environments, it's hard to innovate at the pace that you want to. And the last one that this team had challenged with was the ability to track and share work. So the thing I talked about before, if someone leaves a team, or there's an intern, they're there for 3 months, after they're gone, hopefully you want to pick up their work and you want to productionize it. But how do we do that if we don't have a good tracking system? So these were their challenges, and we went off and implemented a few key changes in their setup using our infrastructure. So we did a longitudinal study in research parlance. This was 3 months. We spent about less than a week in setup, and we worked with their key model, which is the lead classification model. It's a multi-layer model ensembles. They're using scikit-learn. They're also using BERT. It's a combination sort of multimodal situation, NLP and tabular data. They work on millions of documents to make sure that they're capturing an accurate representation of a lead. So here's what we did. We implemented 4 changes. The first one was to instrument all of the new and existing models to do versioning. So do folks use Sacred or any other type of system here? This is an experimentation framework. This helps you keep track of models. And we moved that to Verda because of the flexibility that ModelDB and Verda offer. Once we did that, we installed a central model repository so that whether it was someone working on BERT, someone working on scikit-learn, they could share their models and also do validation in the same place. Because then you can see how is my good old scikit-learn model doing compared to the BERT model. We then hooked up to LDAP, enabled collaboration and sharing. This seems really tedious, but super helpful because now if you're a data science manager, you can quickly see who's building what models, how far are we from the promises we made to the product team or someone in management. The fun thing was they populated over 20K models in a week. It's amazing. That's what we do every day. And yet we don't have a place to store them, so we don't know what our hyperparameter searches are doing and how far we've come. It also surprisingly, or not so surprisingly, helps you streamline the model review process. Because now you're seeing all the experimentation that went on. Your accuracies have error bars, if you're really into statistics. And that stuff turns out to be key. So that's the first change. The second one is enabling the team to run their models at scale. So you're not going to run through millions of documents on your laptop. You're going to have to provision some EC2 machines, salary workers, whatever is appropriate. And doing versioning using a uniform schema lets you package models, whether they are scikit-learn, PyTorch, or TensorFlow, in a way that you can deploy them using the same process. So in our case, it was a one-click deploy, and we helped them scale the workflows without any sort of Celery or AWS hacking. So unless you are a data engineer, this is typically pretty hard, but we take advantage of well-known constructs in Kubernetes and Docker to do the scaling. So that was change 2. Change 3 was validation is still offline. You need to bring it into deployment. And that means you had to follow the best practices around CI/CD. You want to make sure someone peer reviews your code. However, a data scientist should be able to do that. We can't expect data scientists to become Docker experts and then do a lot of DevOps tasks. The key change here, for those of you implementing your own systems, is to adopt a microservices-based architecture. So this means each model is running in its own environment, and you can iterate independent of production code. So production doesn't have to change, even if you want to change something that you do. So that's the model deploy. And the last one we implemented was model monitoring. So before there was a central system for model monitoring, ad hoc checks were like, hey, I'm going to look at this particular file, quickly look at known sort of gold data sets, and make sure that my predictions weren't off the rails. However, automating this allows you to create the kinds of charts that you would create in Looker in order, or Tableau, I guess, to look at your data and its distributions. And the best thing to come out of this is you can actually detect when your model is stale, and you can trigger automated jobs in order to retrain them. So these are all process-oriented things, but making the right tools can make this super, super easy. Cool. So those are the changes that we made. What was the outcome? First of all, model sharing. Before, there was a central repository, no way to share models. They got instant visibility into the 50K models they built over this time period. Now they could search things based on who built a model, or when was it built, or tag models to say that something was in production, something was rolled back, something was a challenger model, green, blue deployments, and so on. Second, a significantly expanded model choice. So not just scikit-learn and Python 2, but they were able to spin up BERT, also XLNet, in a matter of days. And that's something, if you're dependent on an eng team, that's going to take months. Time to test and develop a model. From 22 weeks, we were able to reduce that to 3 weeks. Again, better infrastructure, better processes, you can go a lot faster. Time to deploy a model. So the first one is develop and test. Deploy is actually put it into your production systems. For this particular team, it used to be gated on engineering, but giving the reins of deploying a model with the right processes to the data science team allowed them to go at their pace, as opposed to waiting 3 months for Python 3 to be sanctioned in the production environment. And if you do the math, it actually comes down to, initially they were able to do 2 model deployments a year, and now they're able to do 17. That's more than 1 deployment a month. And if all of us can get to that point, I think we can iterate a lot faster on all of our models and our KPIs. So that's an example of the results one can achieve. I think everyone in this room has some version of infrastructure going on, or you're piecing it together. And the key takeaway here is think about those 4 key challenges or pillars as you're thinking about how to optimize your processes to bring models into production. So quick summary again, model management and rapid deployment are the things that you should be thinking about. And a way to make a case for, if you're a data scientist, make a case for Agile to your managers. It's really, if we can ship, whatever, 10x more models, 8x more models, that's 8x more business impact, product impact, and it can also enable reuse. So hopefully, I convinced you, or began to convince you, that Agile AI and ML is something that you might want to think about and start investing in. And it's actually an application of well-known software practices to data science. And we've seen proof that this works, and we're seeing it over and over again. So what can you do this quarter, right? Or if you're road mapping 2020, what can you do? Implement a central model repo, because you're going to build more models next year and not less, and you might want to get a head start. Empower the data scientists to iterate independent of engineering. They shouldn't have to go and talk to 3 people to put their models in production, or get some time later this quarter. They should be able to do this independently. And finally, think about model monitoring before it becomes an issue, because your data is going to change, the features are going to drop, and get ahead of it before it comes and bites you. Finally, if you're looking for a partner in the transition, at Verda, this is what we spend all of our time on, and we're happy to share our best practices and also help you get set up with some of these things. So that's all I got. Happy to take questions.
That's really validating, because we encourage our students here to do Agile, so it's good to know that there's some...
Also versioning.
Yes.
Yeah.
Yes, they do version control and stuff too. So we don't unfortunately have, oh wait, we do have a question.
Okay.
So from Skander, question regarding the Verda presenter, that's you.
Mm-hmm.
50,000 models were generated by some auto ML framework or by human analysts?
This is human analysts. This is not an auto ML framework. This includes hyperparameter searching. So they are building various kinds of models. They're also building them on different subsets of data. Like you might build them on 3 months, on 6 months, a year, and each one of those things has hyperparameter optimization. So you actually end up building a ton of models very, very quickly.
Okay, great. So actually, I have one other question.
Please.
Would you recommend speaking here?
Yeah.
That's great. So if you go to your digital program, you can find out how to sign up or to apply to speak at one of the Day Science Salon events in the future.
It's a great group, so highly encourage that.
Yeah, it seems like it. Thank you again.
Yep, I'm outside. Happy to take more questions after. Thank you.